Okay, once again, welcome to our classroom. Let us start with a prayer. In the name of the Father, the Son, the Holy Spirit. Lord Jesus, I pray today that you multiply your grace on me, subtract and take away all of my sins by your mercy you have shed on me. Add to my awareness a better understanding of your will for me in my life. I will divide my blessings and grace with those that are not as fortunate as I am. In your perfect and most holy name, I come to you, Jesus, and ask these things. Amen. Hello everyone, I'm your grade 7 mathematics teacher, Maria Eliza Nunez. For this week objectives, we have 3 objectives. First is to translate English phrases to mathematical phrases. Second, differentiates between constants and variables in a given algebraic expression. Third, classifies algebraic expressions which are polynomials according to degree and number of terms. Let us move on with our addition and subtraction of polynomials. So addition and subtraction of polynomials have 3 steps or rules. Step 1, arrange the polynomial in descending or ascending order if possible. What does it mean by descending or ascending order? It focuses on your exponent or the degree that you are seeing on those variable. Step 2, group terms which are similar. Meaning to say, you need to group the terms that are look alike. So you can combine the x with the y's. So x together with the x squared together with the x squared. That's how it says on our step 2. Step 3, add or subtract the numerical coefficients. Applying the rules in subtracting and adding integers, and copy the literal coefficients. So you just add the numbers, copy the letters together with its exponent. Okay, let us have some examples. We have here 5x plus 9y minus 8 plus 7x plus 5y plus 3. How can I combine the similar terms? The easiest way is to write it this way. Write similar terms in the same column. So we have here, as you can see, that is both x, both y, and both constant only. Okay, so we will proceed now. Negative 8 plus 3. You can do it this way or this way, doesn't matter. Negative 8 plus 3 is negative 5. 9y plus 5y. So again, as the step 3 says, add the numerical coefficient, then copy. So we just copy the y. So 9 plus 5 is 14. Copy the y. Later I will show you the whole answer. Next we have 5 plus 7 is 12. Then again, copy the x. And this will be your answer. 12x plus 14y minus 5. Again, just copy the letters. Don't add it. The only thing you need to add are the numbers. Next example. How about if I have now the exponent? And how about if I have now the exponent? Still, you need to copy that exponent. No need to add it. Even though it looks like a number. No need to add the exponent together. We will write it again in column, matching their similar terms. This way. So we have now negative 9 plus negative 7. You will have negative 16. Then next, negative 5 plus negative 8, you will have negative 13. Copy the a. Next, 7a squared plus negative 6a squared. Again, our rules still apply here for the integers. So 7 plus negative 6 will give you 1 only. You can write the 1 if you're comfortable with that. But I can also accept if you just write the a squared. It is acceptable. Next, we have 5 plus 9 is 14. Copy the a cube. So this is the whole answer. As I say, no need to write the 1, but if you're comfortable writing it together with the a squared, it's okay. So you have 14a cubed plus a squared minus 13a minus 16. And next example, we have 5x plus 9y minus 8 minus, so this is subtraction now, minus 7x plus 5y plus 3. Just to recall, in subtraction, we change the sign of the second numbers. So this time, we change the sign of those terms on the second given. Change the sign, then before we go back to the rules of our addition. So this is how it looks. We will write it first in the similar terms by a column. And I already write the additive inverse. So you can see, the positive 7 there becomes negative 7 on my solution. The positive 5y becomes negative 5y. And the positive 3 becomes negative 3. Take note, why did mom put the negative 7x into a parenthesis? It's because for me not to get confused, being this negative being near to my operation sign, which is addition, that look alike a positive sign. So if that case happens, you need to write it in a parenthesis to be clear that that is a sign and the one that is outside is the operation. So we will proceed now to our rules in addition. So we have negative 8 plus negative 3 is negative 11. Then we have 9 plus negative 5 is 4. Copy again the y's. Then 5 plus negative 7x is 5x plus negative 7x is negative 2x. So let us see. So our final answer will now become negative 2x plus 4y minus 11. Take note of the sign. Be careful with our signs. Next example, or last rather, if I'm not mistaken, 12a minus 4b plus 7c minus negative 5a plus 8c. Again, we will write it in column together with its similar terms. Mom, why is it blank there? Because on the next term, we don't have the similar for that 4b. We don't have any variable b. So, just skip it. Then, I already changed the sign. The negative becomes positive. The positive becomes negative. So, we will now proceed to our addition rules. 7c plus negative 8c will give you negative c. Or pwede, you can write negative 1c. It doesn't matter. It's the same. The same with what you're doing when you are subtracting. If there's nothing to be subtract in it, just bring down. So you will bring down negative 4b. Then this one, 12a plus 5a, 17a. So your final answer will be 17a minus 4b minus c. Again, you can write 1 if you are comfortable with writing the 1. Nunez. We have two objectives for this week. First is to evaluate algebraic expressions for given values of the variables. Next, adds and subtracts polynomials. Let us start with evaluating. So to evaluate, substitute the given value in each quantity and perform the indicated operation in cases where grouping symbols such as parentheses, braces, or brackets are involved. Perform the operation within the grouping symbol first before performing other operations, or what we call the PEMDAS rule. So let us have some examples, starting with 4x minus 5y when x is equal to 3 and y is equal to 4. So we need to substitute x with the number 3 and y with the number 4. So how does it look? So it will look like this. It will have 4 times 3 minus 5 times 4. So 4 times 3 is 12 and 5 times 4 is 20. So you will have 12 minus 20. That will give you the answer as negative 8. Next example. Negative 2 quantity A minus 8 plus 3 quantity A plus 5 when A is equal to negative 3. So this is how it says. Let us start with the parentheses. So we will change those letter A with negative 3. So this is how it look. We will now have negative 2 times quantity negative 3 minus 8 plus 3 quantity negative 3 plus 5. So let us start with those in the parentheses. So you will have negative 3 minus 8, that will give you negative 11, and the negative 3 plus 5 will give you positive 2. And this is the next step. Now that you compute those who are in the parentheses, we will now multiply it on the numbers outside. So you will have negative 2 times negative 11 plus 3 times 2. And negative 2 times negative 11 will give you 22. And 3 times 2 will give you 6. So you will have now the statement 22 plus 6. So your final answer will be 28. Next example. Quantity 3y plus 4 plus quantity y minus 6 when y is equal to 5. So this is how we substitute there. As you can see, I put now bracket because the 5 will have the parenthesis as the separation of 3 and 5. So we will have on the bracket, we will have 3 times 5 plus 4. On the other one, we will have parenthesis 5 minus 6. So we will have 3 times 5 is 15 plus 4. This is how it look now. Plus the 5 minus 6, which is negative 1. So this is the step-by-step process. Then now that you have that, you will compute now the 15 plus 4. That will be 19 to be combined to the negative 1. And 19 plus negative 1 will give you 18 as the answer. Next example. 9 quantity 2x minus 5. Again, there's a parenthesis when x is equal to negative 3. So we will have a bracket again. This is how it looks. 9, then the bracket. Then inside the bracket, you will have 2 parenthesis negative 3 minus 5. And we will start again with those that are inside the bracket. So we'll have negative 6 minus 5. After putting that in the parenthesis, that's the first thing to do again. Negative 6 minus 5 will give you negative 11. So you will have 9 times negative 11. Then your final answer will be negative 99. And so when I'm going to look on your output, I want to see this kind of solution, the step-by-step process. Next example, 3a minus 2b plus c. So we have 3 variables now, the a, b, and c. A is for negative 2, b is for 2, and c is for 3. So this is how it will look. 3 times negative 2 minus 2 times 2 plus 3. So it will go continuously since there are no any parentheses. So 3 times negative 2 minus 2 times 2 plus 3. So you will have the 3 times negative 2 is negative 6. Then you have 2 times 2. Then copy the minus. So you have minus 4. Then plus 3. So negative 6 minus 4 plus 3 will give you the answer as negative 7. So you just do it continuously. Next, for the last example, how about if it is in this kind of equation or expression? We have 6ab minus c all over abc. So if a is equal to 5, b is equal to 3, c is equal to 10. So this is how it looks now. So you will have 6 times 5 times 3 minus 10. On the denominator, you will have 5 times 3 times 10. So it's still continuous, but since it's in a fraction, there might be a simplified form at the end of the solution. So you have 6 times 5, that will give you 30, times 3 will give you 90 minus 10. So your numerator will be 80. And for the denominator, you have 5 times 3 is 15 times 10 is 150. So this will be the next step. Writing it as a whole first, you have 80 over 150. And looking at the numerator and denominator, we can simply say that it is still be able to simplify by dividing them into 10. So you have divided 80 into 10, that will be 8, and the 150 into 10 is 15. That will be your final answer. Again, if it is in a fraction form, simplify your answer to the lowest term. So your final answer is 8 over 15, not the 80 over 150. We have here two kinds of symbols. First is symbols of operations, and second is symbols of relations. But our focus for now is symbols of operations. I just add these symbols of relations. For symbols of operations, we have plus. As you can see, here is the symbol for our addition. And the term being used is on the right side. It is plus, more, added to, increase by, the sum of, exceed by, combined by, exceeds together. So when you hear those words, it means you need to add or write this symbol plus. Next is this symbol for our subtraction. It means you can use these following words for that symbol. We have minus, less, subtracted from, decrease by, the difference of, diminish by, lowered by. We also have for our multiplication. This time we have three symbols for multiplication. We have this one that looks like an X, and another one that looks like a dot, and our parenthesis. In your grade 6, you just use this symbol, somewhat letter X. But now, we're gonna use basically the dot or the parenthesis, because that X will have another meaning. Later on, you will find out. And that's the meaning for that symbol is times the product of multiplied by. We also have the symbol for division. But if it is in fraction, written in fraction, you will not see the dot and the numerator and the denominator. But it also means division. And the word using for that is divided by, over, the quotient of, the ratio of. Then for addition information, just addition, we have here the symbols of relation. When you see is less than, that means you're gonna use this symbol, an arrow to the left, and when you see an arrow to the right, it means is greater than, is more than. So, as you can see, all of the meaning of these symbols of relation should start with is. Kapag walang is, that means it is for our symbols of operation. But sometimes we use it for the equal, is equal to. You will see that later. Next, we have here arrow to the left again, but have an underline below. This time it means is less than or equal to, or in a most easier term, is at most. And when you see an arrow to the right with an underline below, it means is greater than or equal to, or is at least. When you see this, you are more popular with this. Is familiar with this. You are all familiar with the symbol is equal to. Sometimes we just use equals. But when in a sentence, it should be used as is equal to, yields, or result is. But when that symbol have a slant line, the meaning will be is not equal to. So that are the meaning for those operations. You will need to remember that, to be familiar with that, so that we can translate the given English phrases later on. Like this. Okay. When we say phrases, as we all know, in English, it doesn't have a complete thought. The same with mathematics. When we have it into mathematical expressions, or what we know as algebraic expressions, it doesn't also have a complete thought because it doesn't include the equal sign or any symbols of relations. Okay, a number increases by 5. You might be asking, why does a number becomes letter M? Okay, this time since we're in algebra, all of the letters can correspond to any number. So we can use any letter if you hear the word a number. From A to Z, you can use. So this time I just use M. And it says increases by 5. So by the word increases, it means addition. So I will have M plus 5. That will be our answer. Next is the difference of 2 and a number. Again, you hear the word and a number. This time I use the letter R. You can use any letter as long as the phrases doesn't say what letter to be used. Then it says the difference, so we need to subtract. So R minus 2. Next is 4 times a certain number. It is multiplication. And it says again, certain number. So I use H this time. But you might be asking, Ma'am, where is the symbol of multiplication in your answer? In algebra, if it says times, it doesn't literally means I need to include the symbol of that. I can just combine those two that is being multiplied. But remember, when you combine, number first before your letter. Next, the difference of 3 times a number and 6. Okay, the same with this. We just add difference of 6. So we have minus 6 and I just use K this time. Next, the quotient of 4 and a number. This is what I'm telling you. Ma'am, where is the symbol of division? I don't need to write the 2 dots up and below because I just say the quotient of 4 and a number. So when I write that over, it already means that I am having division. But take note of the order. It says 4 and a number. So 4 should be the numerator and a number should be a denominator. And this time I use letter D. Next. Okay, here are some definition for you to be familiar with. Algebra is the branch of mathematics that uses letters to represent numbers. So, ito na yung sinabi ko kanina. Okay? That any letters can correspond to any numbers. Next, the definition of our algebraic expression. An algebraic expression is one or more algebraic terms in a phrase. Okay, why does it say one or more? Because there is types of algebraic expression, or later you will find out what's the meaning of or more. It can include variables, constants, and operating symbols. So you already know the operating symbols will be plus, minus, and the over. It's also a phrase, so it doesn't include an equal sign. Remember, it doesn't include an equal sign. Okay, here are what it means when it says one or more. Algebraic expressions are named according to number of terms. Okay, the number of terms can be counted by the separation of the operation. When you see plus, minus in between, you can count it as 1, 2. Later, I will show you. We have here 4 types of that. We have here the monomial. By the word mono, it means one, only one term. By the word binomial, the second one, it means, by the word bi, it means 2 terms. And if we have trinomial, by the word tri, it means 3 terms. But if we have multinomial, or what we call polynomial, from the word poly, it means more terms, more than 3 terms. Here are some examples. When you have monomial, one term, we can have x, 3y, 29, x over 2. Okay. Why does 29 include? It can be included because it says one term. And you will find out what kind of part is that 29 when we discuss it later. We have here the binomial, 2 terms. Examples, x squared plus x. This is what I'm saying. You will count the terms. 1, 2. X cubed minus 2x. 1, 2. Their separation for you to count is that plus, minus only. Don't include the divide. Plus, minus only. If you see that, then that will be your sign to count the number of terms. You need to remember these names because later on it will be on your activity what kind of algebraic expression it is. Monomial, binomial, trinomial. Trinomial includes 3 terms. So we have x squared plus 2x plus 20. So we have 1, 2, 3. 3 terms. Next. Here is the difference between a variable and a constant. A variable is a symbol, usually letters. Letters. From A to Z, again, whatever letters it is a variable, which represent a value or a number. It can represent a value or a number because by next week, it will have a number. The most common designation of variables are x and y. That is the most common or always being used, the x and y. But still, you can use A to Z. And if we have constant, it has a fixed number such as 1, 2, 3, and 4. That is for the constant. Here are some examples. If I have here algebraic expressions, then I will separate the constants and the variables. So for the first one, we have 4y. The constants will be 4. And variable would be y. And for 3s plus 6, we have 3 and 6. Variable is s. 2m over 3, constant 2 and 3. Variable m. Then 7qxy, constant 7. Variables q, x, y. Then we have n, quantity 9 minus b, constants 9. Variables n and b. So, it seems like you're just separating a number from a letter. That's how it is. Next, we also have the degree of polynomials. The degree of polynomials is defined as the highest degree of a monomial within a polynomial. When we say degree, it is the exponent. Later, you will see where is that exponent being found, because you know the constant and the variable. So where is the exponent? Later you will see it in our example. Thus, a polynomial equation having one variable which has the largest exponent is called the degree of the polynomial. Let us have some example. Here, polynomial degree and our example. Our example for the first one is 6. So since it is a constant, it doesn't have a degree. So it has a 0, or what we call constant or zero polynomial, because polynomial have different types also. So here are their names. 3x plus 1. Okay. Why does it have 1 as the degree? Because that x there has an exponent of 1. Remember, it has an exponent of 1, although it is not written there. Next, and it is called linear polynomial. Next, we have 4x squared plus x plus 1. Our highest degree or exponent is 2. Yan. You see it? Our highest degree, nasa taas. Ibig sabihin yun pala yung degree or the exponent is 2. And it is called quadratic polynomial. Next, we have highest degree is 3. And it is called cubic polynomial. Next, highest degree is 4. And it is called quartet polynomial. So those are the types. But we just deal with this quadratic sometimes. But you still see cubic and quartet.